Hi, in this lesson, we'll look at writing classes. Let's go! In the second unit of the course, we learned that methods can have parameters. When writing a new method signature, the parameters that we include in the method signature are referred to as the formal parameters. When we input real values into the parameter list, those real values are referred to as actual parameters. When we write parameters, the data type does not have to match the return type. In this example, the formal parameter int number is passed into the method, and the return type that is being returned to the program is a double. As long as the return type matches the value being returned, parameters do not have to match the return type. When a method is called, the actual parameter must match the formal parameter type. In this case, the value 4 is an int, so this value can be passed to the castDouble method. The actual parameter is then passed to the method and used in the method accordingly. The formal parameter int number is initialized with the value 4 and is then cast to a double. The method then returns the value to the initial program, which prints the value of numCast out to the console. When an actual parameter is a primitive value, the formal parameter is initialized with a copy of that value. Any changes that are made to the formal parameter have no effect on the actual parameter. In this case, int number on the right is initialized to the value 5. When castDouble is called on number, int num is initialized with the value of number, which is 5, and returned to the program to be initialized in the variable numCast. We see that the initial value of number is unchanged, even after castDouble is called on number, because a copy of the value is passed to the method, not the actual variable number. While primitive values pass copies to a method parameter, a reference variable will pass a copy of the reference, not a copy of the object. This means that any changes made to a reference variable in a method will affect the original reference. As we see here, the original value of rect1 changes after rect1 is passed through resetRect. This is because the formal parameter rect in the method resetRect is a copy of the existing reference, making an alias of the actual parameter that is being passed. If the formal parameter is a reference object, we can actually access the private data associated with that reference if the method has been written in the objects class file. In this example, because my program is not the file that the rectangle class was written in, we have to use rect.setWidth and rect.setHeight to access the instance variables. If the method was written inside the rectangle class file, then we could access the object's data by using the dot variable notation. Notice that instead of using setWidth and setHeight, we can just change the value of width and height by writing rect.width and rect.height. This works when the parameter reference object is the same as the class file. If we tried to do this same thing in the myprogram.java file, it would throw an error, as the instance variables width and height have private access and can only be used directly in the rectangle.java file. Generally speaking, it's good programming practice to avoid altering objects within methods, unless the method specifically calls for alterations to the object. Accessor and getter methods make obvious changes to objects, but most methods should not attempt to make changes unless it's explicitly necessary. Now that you've learned more about writing classes, let's get some practice using them in the CodeHS editor.